This is Yashika from Right Mind Tutors. Today we will be discussing electrolysis. Electrolysis is one of the most important topic for your IGCSEs as well as your GCSEs. And it is, approximately 6 to 8 marks, and most of the kids feel it is quite hard chapter. So let's try to discuss few tricks related to electrolysis. And I feel, the moment you see this video, this is gonna be like this chapter is gonna be little on the easier side for you. Okay, so let's start. So let's discuss the basic definition of the electrolysis first. What is it? The electrolysis means breaking down using electricity. So we will be doing a chemical reaction but using electricity. Electricity is going to be the driving force in the chemical reaction. Okay, the compound that is broken down by the electrolysis is known as electrolyte. So electrolyte is something, it's a kind of compound that's going to be participating in the electrolysis, and we're going to be breaking that electrolyte into its, cation, that is cation, and anion or anion. Cation means positively charged, and anion means negatively charged. So we are breaking it. Okay, and basically electric current is used to break down the ionic compound. So sometimes the electrolyte word do pop up in your exam. You can pay attention to the word. Otherwise, it's just a kind of basic introduction. So next is apparatus for electrolysis. So if I look at the apparatus for electrolysis, what I have got is I have a beaker. I have two electrodes connected to a wire. The wire is connected to a battery. That's it. So about these electrodes, this and this, these are my electrodes. Okay, electrodes are of two types, cathodes and anodes. And electrodes, the electrodes we're going to be taking in this electrolysis, they are inert in nature. What do you mean by the word inert? Any guesses? Inert means they won't be reacting. Inert means non-reactive, like they won't be participating in the reaction. Whatever the reaction is going on in the beaker, the electrodes won't participate in it. Like they are just, just for the conduction of charge. That's it. They are sitting, conducting the charge. That's it. About these non-reactives, you can take graphite. Okay, graphite is one electrode type, that's a form of carbon solid, or you can take platinum. Platinum is a noble metal that usually don't react. Now the other part you need to keep in mind is platinum is little on the expensive side and graphite is little on the economically viable electrode for us. I hope that works. So one of the electrode, the anode one, is the one that's attached to the positive terminal of the battery, and the cathode is the one that's attached to the negative terminal of battery. So next, I'm going to teach a trick, like a pretty nice trick, and this is going to be solving the entire electrolysis problem for you, I feel. So you have to remember the word panic. Panic means positive anode and negative cathode. Okay, negative cathode. And then you have the other trick word anox and red cat. So anode is the place of oxidation, anode oxidation, and cathode is reduction, reduction cathode. Do learn it, learn this. This is IMP, important for your GCSEs. This is a kind of trick, you can actually solve the entire question using this. Okay, let's move further. Again, now this is like a sure, like I'll say 90% possibility of this thing to come in your paper. It's going to come in form of like 2 or more questions. I'll be framing those questions for you. Let's give a read first what they're trying to say. So they say is basically ionic compounds can only be electrolyzed when, like they can be electrolyzed when they are molten or dissolved in water. So two states are possible. Either you need to take the molten state of the ionic compound, or you need to take the form that is dissolved in water. Why? Because their ions are free to move and carry the charge to the electrodes. if they aren't in out of any of these two forms, if you take them in any third form, electrolysis won't be possible because the ions no longer will be available. So I can summarize it for you. Ionic compounds are actually, available in three states. Solid, molten is actually the liquid state only, molten or liquid state. Like liquid means you have actually melted them to a pretty high temperature. And the last one is aqueous. Aqueous means dissolved in water. So in the solids, what is thing? They are fixed. Fixed, no movement. No movement, therefore, no charge conduction possible. Okay, whereas in molten and aqueous, what happens? This is the reason the charge is free to move and therefore they can conduct electricity. I hope it works for you. Now, let me try to frame the question for you. So maybe the question would be, let's say, why ionic compounds conduct electricity when they are molten? Why they don't conduct electricity when they are solid? Or, for the electrolysis, why we need the ionic compounds in the molten or in the aqueous state? Why the solid is not, good option for us? So I hope it works. Like these three things will be there for you. Do note this, pretty important, 90% chance it's going to pop up in your exam, either in paper one or sometimes in the paper two as well. I hope it works for you till now. Okay, so now we will be using this trick and doing the electrolysis of molten lead bromide. So if you know here, lead bromide, lead 2 is that I can derive the chemical formula that would be PbBr2. That's it. So now what I'm going to be doing is I'll be trying to, write the types of available ions. Like if I have the molten lead bromide means I have actually melted my lead bromide, and what type of available ions will be there? Let's write it. Available ions will be Pb2 plus and Br minus. These two will be there because it's melted. Nothing else is there. Okay, then I have this whole setup with me, molten lead bromide. I have my positive one is what? Anode is the positive side and cathode is what? Negative side, sure. See, panic word is there, positive anode, negative cathode. Okay, great. So let's write reaction at cathode. So reaction at cathode. So if I try to write the reaction at cathode first, cathode is negative, so it will attract positive. It will attract positive ion, correct? It will attract positive ion. Okay, positive is what? Pb2 plus. Perfect. Now, reduction at cathode. This is the word anox, red cat. Okay, anox and red cat means reduction at cathode. So I'll be reducing the Pb2 plus. What is reduction? Reduction is gain of electrons. So Pb2 plus will be gaining 2 electrons and it will be changing to Pb. That's the reaction taking place at cathode. Next would be reaction at anode. Okay, so anode is what? It's positive in nature. Positive gonna attract negative. So it will attract negative ion. Would you mind looking what negative ion do we have? We have Br minus. Br minus would be attracted. So I can write here Br minus. That would be attracted. Now let's try to write the reaction. What's going to happen? Br minus 2, it's going to make Br2. That's going to be the reaction. But what does reaction anode pay? Oxidation. At anode, the oxidation takes place. Oxidation is the loss of electrons. So I'll be putting 2 electrons here. That is the electrolysis part for the molten things. Hope it works for you. Okay, electrolysis of molten lead bromide. But is it okay? Fine. Now let's move to the electrolysis of the ionic compounds. For the ionic parts, you have to keep few things in mind. The thing is, like, let's take the, electrolysis of aqueous compounds, aqueous ionics. Aqueous ionics means we have ionic compound dissolved in water. Okay, dissolved in H2O. So let's try to do that. For that particular thing, you have to, like, let's say I'm writing NaCl aqueous. So the available ions will be, now aqueous means you do have the water also. So you will get Na plus Cl minus. Aqueous means you would have H plus OH minus. So 4 types of ions are available for me. Correct? So 4 available ions are there. So now how I know, out of these, which one will get oxidized and which one's gonna get reduced? I have no clue for that. Correct? So let's try to look into it. So for this, we have something known as reactivity series. So this is my reactivity series. As you go down, what happens? Reactivity decreases. Okay. Reactivity decreases, therefore the less reactive, that particular thing would get reduced. Okay, reactive means I want to stay in the charged state. Word reactive means it loves to stay in charged state. Okay, if it's like like if you have the competition between K plus and H plus, H plus lies somewhere here and the K plus is here. K is more reactive. K, if there is a competition between K plus and H plus, K plus says, oh, I am more reactive, I would be staying in K plus only. H plus, you get reduced. Okay, so I'm writing a short thing for you in the box. Try to copy it. More reactive will remain as it is, whereas less reactive ion will be reduced. Pretty important, learn it. Learn it. Okay. Any doubts so far? You can comment down if you have got any doubt. Okay. I'll be trying to answer your doubt. Fine. So now about, this is fine, if I talk about the competition now here, sodium is this is hydrogen. So obviously sodium is more reactive, hence here in this example, hydrogen will be reduced. Correct? But now what about the Cl minus and OH minus? So for the order of discharge potential at anode, what's going to be happening here? Like if you have got the competition between halide, hydroxide and any other charged ion, halides are preferred over hydroxides. Hydroxides are preferred over any negative. Any negative may you could have sulfate, which is SO4 2 minus. You can have nitrate, which is NO3 minus, and the carbonates. For the carbonate, I want you to, comment down the chemical, formula for the carbonates. Fine. So like here I have got a Cl minus and OH minus. Check. Halides are preferred. So therefore, Cl minus will be oxidized. Okay, and OH minus remain as it is. OH minus remain as it is in solution. Any doubts so far? Do let me know in the comment section if you have got any doubt. We will try to clarify your doubt. Okay, fine. So let's move further. And let's do the electrolysis of copper sulfate, aqueous copper sulfate. This is a pretty high chance question for your IGCSEs and GCSEs. I'll be doing and trying to discuss the possible questions out of it as well. Okay, so I have the aqueous copper sulfate. The very first step is what? Write the available ions. So see, it is aqueous. Aqueous means we do have the water with us as well. So I'll have H plus, OH minus, copper 2 plus, SO4 2 minus. From where H plus and OH minus are coming? They are coming from H2O dissociation. Like as the water dissociation means as the water breaks up, it releases H plus and OH minus. So let's try to write the reactions now. Reaction at cathode. What's going to happen? Cathode is positive or negative? Panic. Negative cathode. So it's negative, so it attracts positive ions. Positive ions, I have what? I have H plus and copper 2 plus. So let's go to the reactivity series. Copper 2 plus is less reactive. So more reactive remain as it is, less reactive would be reduced. So what happens? Copper 2 plus 2 electrons form copper solid. You can put as aqueous here. So H plus remains as it is. Okay, because it is more reactive. Perfect. So next, let me write the reaction at anode. Panic. Positive is anode. So it attracts negative ions. Now we have that word also, anox and red cat. Anox means anode is the place of oxidation. So negative mein what we are having is we have OH minus and SO4 2 minus. Now we know OH is preferred over any, sulfates, nitrates, carbonates. So what's going to happen here? Okay, for this part you have to actually learn the OH reduction, OH oxidation part, because it's quite hard. So what happened here is 4 OH minuses actually changes to O2 plus 2 water plus 4 electrons. Try to learn it. Learn it, please. Okay. I hope it works for you guys. So that's it. Okay. Try to note it down. Now look at the observation part. Like what observations are there? So if you look, copper sulfate is blue in color. So what happens after you do the electrolysis? The blue color is gone because now you no longer have copper available in the solution. You have sulfate ions and H plus ions left. That's it. OH changes to oxygen and copper 2 plus changes to copper solid. So the blue color disappears. And then there will be effervescence or bubbling at anode. Why? Again, one question. Because at anode, O2 gas is getting liberated. If O2 gas is liberated at anode, what you will observe effervescence or bubblings. I hope it's fine. Next important question is, after some time, anode actually corrodes, or it's like we need to replace the anode occasionally for this particular reaction. Why anode need to be replaced? Like anode actually corrodes or need replacement. This is the most important question, and like it comes, but sometimes, and this is one of a kind question. This is like a hard question. There is no way you can guess it. The answer is basically O2 is getting liberated at anode, and anode is made up of carbon. So carbon plus O2 forms CO2. So actually your electrode starts reacting with oxygen. That's why your electrode needs, replacements after a few electrolysis reaction taking place at it. Okay, this is like this question comes like this is one of the questions, so pay attention and maybe note it, like note it down. Okay, fine. So that's it for your electrolysis. Let's try to, quickly summarize this entire process. So what you need to do is you need to check whether it's aqueous or molten. If it's molten, what you do? Cathode, metal is formed, and anode, non-metal. Non-metal changes to the gas, changes to its gas. Okay, like if you have halogens or halides, they changes to, like you have 2Cl minus, it will give rise to chlorine 2. or like Br minus changes to Br2, like these. Okay, and if you have the aqueous ones, what happens at cathode? Check reactivity, series, and less reactive is reduced. Okay, and for anode, you need to check halide followed by OH minus followed by SO4 2 minus. This, okay? That's it. I hope it works for you. Do try to note it. And in the next video, we probably will be discussing the questions related to the electrolysis, your past year papers. If you have any doubt in the entire video, you can drop in the comment section. Our team will get back to you. Okay, bye-bye. Take care. Happy learning.